The astonishing technological advancements of recent decades have had a profound impact on how we live, work, and communicate. Artificial intelligence incorporates numerous cutting-edge and upcoming technologies. Many more models should be introduced to you. In this video, let's discuss a few AI innovations like Aria, Open Interpreter, and more. So let's get started. Firstly, let's have a look at Opera's new AI chatbot named Aria. Opera has released Opera 1, an updated version of its well-known browser that has Aria, a unique AI-powered chatbot. Aria uses OpenAI's GPT model and Opera's Composer AI engine to give real-time information, text-generating capabilities, brainstorming aids, and much more. It is similar to the Bing chatbot on Microsoft Edge. By enabling users to highlight text directly on a website, Aria goes beyond standard surfing help. A contextual menu with features like translation, explanation, and related subject search is displayed when a specific section of text is selected. The user's capacity to learn more and explore deeper into the content they come across, while this feature improves browsing. The capability of Aria to function outside of the sidebar is one of its unique features. Unlike Bing, Aria enables rapid and direct interaction without opening the sidebar through the use of a command line overlay. Both Aria and Bing can highlight text, but Aria goes one step further by giving users a rich contextual menu. Using the highlighted text as a guide, users can utilize this menu to translate, clarify, or research related subjects. In addition to the AI chatbot, Opera GX is gaining a brand new command line that enables users to communicate with Aria through their browser by using the Ctrl Plus or CMD Plus keyboard shortcuts in Windows or Mac, respectively. Users are better able to grasp the content they encounter thanks to this feature, which also encourages greater web involvement. On Windows and macOS, as well as in the main Opera app for Android and iOS, the new AI experience is accessible in more than 180 nations. It is also available in the gaming-specific Opera GX browser. Moving on to the next one. Is it possible to detect cancer with AI? Well, yes. Introducing Cancer AI, the application of artificial intelligence, or AI, is growing in many facets of our lives, including the diagnosis of cancer. Building tools for cancer diagnosis and detection using machine learning could help researchers find tumors or abnormalities that medical professionals would miss. Additionally, AI is being utilized to assist in patient therapy or to communicate with patients about the difficulties associated with their cancer therapies. Despite the advances, experts caution that there are still limitations, including biases in the detection of tumors in white patients compared to patients of color, and legitimate concerns that cancers may be overdiagnosed, which could be useful for cancer patients receiving therapy. To help patients navigate their complex cancer treatment regimens and lower the possibility of errors, Penn Medicine created an AI chatbot called Penny that texted with them. The program correctly read more than 90% of signals, according to the results, and individuals took their meds with at least a 70% adherence rate. Radiologists and oncologists can use these machine learning algorithms to analyze images and data, identifying areas of interest for further inquiry and assisting in the early detection of anomalies that could save countless lives. By facilitating early detection, precise diagnosis, individualized treatment, and increased workflow effectiveness, artificial intelligence is revolutionizing the field of cancer imaging. AI-powered cancer imaging is positioned to be a game-changer in boosting cancer diagnosis rates, lowering false positives and false negatives, and eventually saving lives as technology develops. To overcome obstacles and ensure its ethical and responsible usage, researchers, medical professionals, and governments must work together to embrace AI in cancer imaging. Even if the potential advantages of AI in cancer imaging are encouraging, it is crucial to address the difficulties and ethical issues that crop up. When handling sensitive medical information, it is also crucial to ensure patient privacy and data security. The next one is the Open Interpreter. An AL-driven program called Open Interpreter enables users to run code locally on their computers. Open Interpreter sets itself apart from other code interpreters by being able to directly comprehend and generate code from natural language descriptions, as opposed to conventional code interpreters that translate high-level programming languages into machine-understandable code. Users can interact with the tool as if they were having a conversation by using the interface, which is essentially similar to ChatGPT. The capacity of Open Interpreter to decipher and produce code from descriptions in plain language is one of its most remarkable qualities. As a result, users can use plain English to describe coding tasks, and Open Interpreter will translate such descriptions into executable code. By adopting a chat-like user interface, Open Interpreter is made more approachable and user-friendly, especially for people who are already accustomed to chatbots. By typing the command interpreter into their terminal, users can start interactive sessions with Open Interpreter, basically initiating a dialogue. It performs jobs involving data exceptionally well, which is a game changer for data scientists and analysts. Open Interpreter allows users to clean up complex datasets, create graphs, and do in-depth data analysis. Open Interpreter is open-source software that anybody can use and modify without charge. Because of the collaborative environment that is fostered by this openness, developers are always able to improve and broaden their capabilities. One line of code at a time is retrieved, examined, and executed to make this work. It interprets user-provided descriptions in natural language into code, executes that code locally, and then processes the result. The accuracy of this methodical execution procedure is guaranteed, and users may closely watch and manage the code's execution. The next is all about the Falcon 180B large language model. The Falcon 180B establishes a new benchmark for open models. It was trained on an enormous 3.5 trillion tokens using TII's refined web dataset, and it has 180 billion parameters, making it the largest publicly available language model. This is the open model's longest single epoch pre-training. In terms of architecture, Falcon 180B is a scaled-up version of Falcon 40B and builds on its innovations for better scalability, such as multi-query attention. Falcon 180B was trained on 3.5 trillion tokens using Amazon SageMaker on up to 4,096 GPUs at once for a total of about 7 million GPU hours. Accordingly, Falcon 180B is 2.5 times bigger than Llama 2 and was trained using 4 times as much computing power. But why is there such a buzz about it in the AI community? With Falcon 180B, language model creation is expected to advance significantly. With 180 billion parameters, it offers remarkable performance and sets itself apart from the competition with better accessibility and versatility. Falcon 180B, in contrast to closed-source devices like GPT-4, is intended for both research and commercial use. The LLM includes a unique distributed training codebase that makes use of 3D parallelism with Zero and unique Trion kernels. The system required a lot of work to create, using up to 4,096 GPUs at once for 7 million GPU hours. Due to this, Falcon 180B is around 2.5 times larger than rival models like Llama 2. According to TII, the chat model has already been refined using training data, chat datasets, and a number of sizable conversational datasets. Falcon 180B is a super effective language model that can adapt to a variety of tasks, including coding and knowledge testing if all of that seems terribly perplexing. The last one is MindViz. Based on brain activity, a new AI model dubbed MindViz can decipher what a person is viewing. The mnemonic invariants that are present in the brain when a person views an object are interpreted by the model to explain how it functions. These mnemonic invariants are patterns that hold while recalling the same object in various ways. The diffusion model's underlying concept is rather straightforward. How do they change the final image? The explanation is that they are employed to condition the network such that the process of progressive denoising proceeds in a particular manner. The question is, how can we record the data in the brain? These gadgets can scan the brain's activity. On the other hand, fMRI is a sort of medical imaging technique that creates precise images of the brain using a magnetic field and radio waves. fMRI allows for the creation of dynamic images of the brain that display variations in activity over time, in contrast to standard MRI, which only generates static images of the brain. Therefore, MindViz integrates these two approaches to produce a trustworthy stimuli decoding model. It makes use of large-scale dataset learning and imitates the sparse coding of information in the brain. Using brain recording and a small number of training pairs, MindViz is able to create meaningful visuals with matching information. And that's all about it. If you find this video informative, please give a thumbs up. And if you like more updated AI news, subscribe to our channel. And don't forget to click on the bell icon to not miss out on any video and to get notifications on time. Don't hesitate to give suggestions for our videos. See you in the next one.